How much would you be willing to play this spinner game? Spin the spinner, and however much, whatever it lands on, that's how much you win. Pretty cool, it spins. What would you need to know in order to make a decision about how much you would be willing to pay? Maybe you'd want to know how likely you are to win. Maybe you'd like to know what the average winnings would be. So to do this, we can create the probability distribution of a random variable. A random variable is just a variable that takes on values based on random chance. So in this case, the values of the variable, we're going to say x, we're going to name the variable x and say x is equal to the amount you win. Okay, so what are the different possibilities for x? Well, x could be as little as negative $10, okay, so you lose $10. You could also lose $3. You could win $1. You could win $5, or you could win $20. So $1, $5, and $20. Now we can create a probability distribution for x and list the probability of each of these occurrences happening. So there are 10 equally sized spaces. So there's a 0.1 probability of getting negative 10, a 0.1 probability of getting negative 3. There are 5 ways to get $1, so a 0.5 probability, 5 out of 10 for 1, 2 out of 10 for 5, and 1 out of 10 for 20. So this is known as a probability distribution. I could also make a probability distribution using a histogram. So if I called this 0, let's say this is negative 10 and negative 5. I think I'll just label this. I may just label these using the values that we have and kind of space them out accordingly. So we have negative 10, we have negative 3, we have positive 1, positive 5, and then 20. And then we could look at each of these being 1/10, 0.1, 0.2, 0.3, 0.4, 0.5. So I have a 1/10 chance of a 10, a 1/10 chance of a, or negative 10, negative 3, 5/10 chance of a 1, 2/10 of a 5, and 1/10 of a 20. So both of these are probability distributions showing how the different outcomes are likely to occur. Now, we can use this information then to investigate our question. How much would you be willing to pay to play this game? Well, we know we can look at the probability of winning. The probability of winning something would be 0.5 plus 0.2 plus 0.1. All of those would involve winning. So we have an 80% chance of winning something. If you want to know how much, if you wanted a big win, so the probability of winning more than $1, so we're probably that x is greater than 1, then would be a 0.3. Probability that x equals the big $20 payoff would be 0.1. So would you be willing to pay $1 to play the game? A couple dollars? Let's investigate the average now. Let's think about that. So if I wanted to know what the average amount I would win, notice I have 10 equally likely outcomes here. So if we think about just doing a typical average, we could say that the average winnings would be, and I'm just going to add these up, starting with the 1 here. I have $1 plus $5 plus another $1, and I'm doing these separately for a reason. Plus negative 10, plus 1, plus 5, plus 1, plus negative 3, plus 1, and plus 20. And since they're all equally likely, we can divide this by 10. And if you add all of these up, it turns out to be $22 divided by 10, or $2.2. Now, based on that, what I think, oh well, the average amount you win is $2.2, so would I be willing to pay something less than maybe pay $2 per game? So the question is, if I paid $2 per game, realize there's only a 30% chance of getting more than your money back. You know, you can only get $5 or $10 or $20 30% of the time. So maybe that's not that wouldn't be enough to convince you. What exactly does the $2.2 mean? It means that if you played the game many, many, many times, the average amount you would win per game is $2.2. But you would have to play the game many, many, many times for that to happen. Now this is an important number that we want to calculate for a probability distribution like this, or for the distribution of a random variable. So we have something called the expected value. The expected value of the random variable is also known as the mean. How is this calculated? Well, let's take a look at the spread of values that we had here. We added up all the values and divided by 10. Let's write this in a little bit more concise way. So notice that we have $1 repeated 5 times. So I'm going to say that the expected value, or the mean of x, is $1 times 5. We have 5 different ways to get $1. There are 2 different ways to get $5, so we have $5 times 2. And then each of the other outcomes only occur once. So we have negative $10 times 1 plus negative $3 times 1 plus $20 times 1. And these are all divided by 10. So let's imagine then dividing each of them by 10. Since the entire thing is divided by 10, if we divided each individual thing by 10, we would have this. $1 times 5/10 plus $5 times 2/10 plus negative $10 times 1/10 plus negative $3 times 1/10 plus $20 times 1/10. Notice that all this is each of the outcomes multiplied times its probability and added together. We can symbolize this using the formula for expected value. The sum of all of the possible outcomes times their probabilities. So when we would do this for this particular problem, it would look like this. And using our chart up above, I'm going to do it in that order. It would be negative 10 times 0.1 plus negative 3 times 0.1 plus 1 times 0.5 plus 5 times 0.2 plus 20 times 0.1. And that's known as the expected value, or the mean. Another piece of information we might want to know about this distribution is how much that the individual outcomes vary from the mean. So if we want to look at variation, we look at something called variance, or standard deviation, which is the square root of variance. There's a formula on your formula sheet for variance. And the formula reads like this. The variance of x is equal to the sum of xi minus mu sub x squared times p sub I. So what exactly is that saying? It's saying we start by taking each outcome and subtracting the mean to see how far away it is from the mean. If we did that for each outcome, we would notice that some values are less than the mean and some values are greater than the mean. If we added up all those differences, remember, they would just add up to 0, because that's what the mean does, is it averages those distances from the mean, positive and negative. So we square those just to create one numerical summary of that variation. But we also have to recognize that each of those differences occur with different probabilities, so we have to multiply each one times its probability. So it would look like this. We would do negative 10 minus 2.2 squared times its probability, which is 0.1, plus negative 3 minus 2.2 squared times 0.1, plus 1 minus 2.2 squared times 0.5, plus 5 minus 2.2 squared times 0.2, plus 20 minus 2.2 squared times 0.1. And when we add all those up, that gives us the variance. However, you will notice then that variance is equal to the standard deviation squared of x. So if I want to know standard deviation of x, I'm going to take the square root of the variance. So if I take the square root of all of this, I end up with this number, and I think I have it on my calculator here. Yes. I'm going to go back and look at this. I end up doing that whole process on my calculator. I end up with $7.18. Now, we did this on the calculator by typing in very tediously this entire thing, the square root of all of those terms. And that is one way to do it. However, it is very long and tiresome to type in, to do it that way. So what are you required to show for me or for the AP exam? You would be required to show that you can set the formula up like this or like this. But then, after setting the formula up, then you can do the actual computation on your calculator. So to set up the computation on your calculator, it would look like this. You would need to go to a document and make two lists. So I made a list. Let me go up here, up arrow 1. I made two lists. One list had all the possible outcomes. The other list had all of their probabilities. Then I did one variable stats using those two lists, the list of the data with its frequency. So if you go to the calculator page, go to data, go to menu, 6 statistics, 1 stat calculation, 1 variable statistics. Now notice I'm not using two lists, I'm only using one list because only one list has data in it. So my X1 list, my list of winnings, it goes here. The frequency list, and instead of saying the frequency of each value is 1, now my frequency is my probability list that I did. So when I do this, I notice here's my 2.2 and there's my 7.18. So I can calculate this fairly quickly using lists as opposed to typing in the entire formula by hand. So set up the formula and then calculate it any way you want to using your calculator. So to sum up what we've talked about here, actually let's go back and answer this question again. How much would you be willing to pay to play this game? So knowing the probability of winning anything at all is 0.8. The probability of winning something more than $1 is 0.3. The probability of winning $20 is 1. If you played the game a lot of times, you would have a $2.20 average winning with a variability of 7.18. So this is the typical amount that your winnings vary from the mean. Your winning amount varies from the mean, which would be varies from $2.20. So notice we could have a really large swing, anywhere from negative, the typical amount, -5 to positive $9. A lot of variation in what you might win. So maybe you would say, hey, I'm willing to pay $1 to play this game because, half the time I'll break even and another 30% of the time I'll win some money, and I'll only lose some money 20% of the time. So maybe I'd be willing to pay $1. But what about the person who's in charge of running the game? How much would you charge to play? How much would you charge someone to play the game? If you were running the game like at a carnival or something, or at a casino, what would you pay to play? Have them pay to play? It would have to be more than $2.20, or have to be more than $2.20, because if your average payout is $2.20 per game, you would have to charge them more than $2.20 per game. Not sure if you'd get people to play with that. Maybe they'd be willing, for the chance of winning 20 or 5, they'd be willing to pay maybe $2.50, maybe. But then they would realize that 70% of the time they're going to lose money, so maybe they wouldn't. But that's basically what anybody running a game of chance has to decide, is they have to find this expected value and this amount of variability, and they have to decide how much they're going to charge someone so that they make money, but yet it's low enough that the person would still want to play the game. Alright, let's take a look then at summarizing what we've talked about. A random variable is a numerical outcome of a chance process. A probability distribution identifies the possible values of the variable and how likely they are. The probability distribution can be displayed as a table or a histogram, and probably some other types of graphs, but histogram is usually typical. The expected value, or the mean, of the random variable describes the average value of the variable if the chance process is repeated many times. And then here are the formulas. The first two are found on the AP formula sheet. So the variance formula and the expected value formula are exactly as shown on the AP formula sheet. This is just something you need to know. You need to know that the standard deviation is the square root of the variance. It might help you to remember that sigma stands for standard deviation, and you see the sigma squared here, so that might help you out with that. Something else to be aware of, and you might want to write this just below your box right here, is that expected value may not equal any one of the outcomes. In the case of our example, none of the outcomes was $2.20, but that was what our expected value would be. Another thing you need to remember is do not round the expected value. It might be tempting in situations where the expected value doesn't make sense. So maybe you're looking at the expected number of children per household and you end up with something like 1.7, and you say, well, I can't have 1.7 children, I'll round it to 2. Don't do that. The expected value isn't necessarily a whole number, and you need to leave it in its unrounded form.